Good morning children, welcome back. Today we are going to see coordination compounds part 4. Hope all of you must have completed part 1, part 2 and part 3 of coordination compounds. In part 4 we will be learning about valence bond theory. If you have not completed part 1, 2 and 3, you can look at the description box. I have given you the links for part 1, 2 and 3. So you can go through that. Already we have learnt Werner's coordination theory, in which case we have seen that the bonding between the central metal ion and the ligand in the case of Werner's coordination theory is considered to be the bonding between Lewis acid and Lewis base. The central metal ion is considered to be Lewis acid and the ligand is considered to be Lewis base. And he could answer so many questions, but his theory cannot explain certain questions like why only certain elements are forming coordination compounds and others does not. Second question, why the bonds in coordination compounds have directional properties. And third one, why do they show magnetic and optical properties. These three questions cannot be answered by Werner's coordination theory, so we are in search of other theories. The first theory is called as valence bond theory. This was proposed by Linus Pauling. He assumes that the bond between the central metal atom and the ligand is purely covalent. Already you know what is covalent bond. Covalent bond is formed by mutual sharing of electrons. Here the central metal atom will have unfilled or vacant orbital and the ligand will have filled orbital. So the vacant orbitals of the central metal atom will overlap with the filled ligand orbitals which contains the lone pair of electron. Both will form the bonding. The actual bonding is formed between the central metal atom which has vacancy in the orbital and the ligand will have filled orbital. Both overlaps to form the hybrid orbital. What are the main assumptions of valence bond theory? As I told you, the bonding between the ligand and the central metal atom is purely covalent. That is, it is formed due to sharing of electrons. The sharing comes only from ligand. Ligand gives its electron to the central metal atom. Here you can see in nickel tetracarbonyl, carbonyl donates a pair of electron. That is, it shares its electron to nickel and forms its bond. That is the first point. Second one, each ligand should have at least one filled orbital containing a lone pair of electron. The first condition is that the ligand and metal forms the bond which is purely covalent. The sharing comes from the electrons are coming only from ligand. And second point, in order to give electron, the ligand must have at least one filled orbital. That is one lone pair of electron, as I showed you. Then if the electron is donated by the ligand, it must be accepted by the central metal atom. So if the central metal atom or ion has to accept the electron, it must have vacancy. So in order to accommodate the electron pairs donated by the ligands, the central metal ion present in the complex provides required number of vacant orbitals. Suppose if the ligand number is 4, then the central metal atom creates 4 vacancies. If the ligand is 6 in number, the central metal atom will create 6 vacant orbitals. So in order to accommodate the electron donated by the ligands, the central metal atom make available vacant orbitals. Already I told you the central metal atom or ion will create enough number of vacant orbitals. That's third point. என்ன சொன்னாங்க, ஃபர்ஸ்ட் பாயிண்டில் பாண்டிங் இஸ் பியூர்லி கோவேலன்ட் சொல்லிட்டாங்க. செகண்ட் பாயிண்டில் லிகேண்ட் மஸ்ட் ஹேவ் அட்லீஸ்ட் ஒன் லோன் பேர் ஆஃப் எலக்ட்ரான். தேர்ட் பாயிண்டில் எத்தனை லிகேண்ட் இருக்கோ அத்தனை வேக்கண்ட் ஆர்பிட்டால்ஸ் இருக்கும். ஃபோர்த் பாயிண்டில் தீஸ் வேக்கண்ட் ஆர்பிட்டால்ஸ் ஆஃப் த சென்ட்ரல் மெட்டல் ஆட்டம் வில் அண்டர்கோ எ ப்ராசஸ் கால்ட் ஹைப்ரிடைசேஷன். அந்த சென்ட்ரல் மெட்டல் அயானில் இருக்கக்கூடிய வேக்கண்ட் ஆர்பிட்டால்ஸ் எல்லாமே தே வில் ஹைப்ரிடைஸ் தெம்செல்வ்ஸ். தே வில் ஃபார்ம் அ hybrid orbital. What is hybridization? Intermixing of atomic orbitals of comparable energy to form equal number of orbitals, which are called as hybridized orbitals. Okay, so hybrid orbital form ஆயிடுச்சு. Fifth point என்ன அப்படின்னா, இப்போ அந்த வேக்கண்ட் ஆர்பிட்டால்லாம் ஹைப்ரைஸ் ஆகிருக்கா, அந்த ஹைப்ரிட் ஆர்பிட்டால்ஸ் ஆஃப் சென்ட்ரல் மெட்டல் அயான் will overlap with the ligand filled orbital. Ligand will have filled orbital. அது கூட it will start overlapping and both will form coordinate covalent sigma bonds. This is fifth point. Sixth point பார்த்தீங்கன்னா, இந்த hybridized orbital எல்லாம் they will have a definite shape. They will provide definite geometry as well as they are directional and the ligands are oriented in space, giving a definite geometry to the complex ion. Here is a list of hybridized orbital and its shape, geometry and the hybridization given. If the coordination number is 2, you know what is coordination number? Number of bonds formed between the central metal atom and the ligand. If the bonding is only 2, then the hybridization is sp, the geometry is linear. For that I have given you example. If it is 3, then the hybridization is sp2, geometry is trigonal planar. If 4, if the coordination number is 4, it may have either sp3 hybridization or dsp2 hybridization. If sp3 is the hybridization, then the geometry is tetrahedral. If dsp2 is the hybridization, then its geometry is square planar. If 5 is the coordination number, the hybridization will be sp3d, in which case dx square minus y square orbital is involved. That is the last orbital. Dx square minus y square orbital is involved. If the hybridization is sp3d, then the shape is trigonal bipyramidal. And if the coordination number is 6, then the hybridization may be either d2sp3 or sp3d2. Both will give only octahedral shape. If it is d2sp3, that means inner d orbital is taken into account. That we'll see later. And sp3d2 means they are taking outer d orbital. And all the examples you must be very thorough with. In order to understand the seventh point, you must be very clear about what is nth shell and what is n minus 1th shell. What is nth shell? The outermost shell of the atom. If you consider n minus 1th shell, which is n minus 1, next to 2, that is inner to outer shell. Nth shell kulla irukradha n minus 1. Suppose if n minus 1 d orbital நம்ம hybridization க்கு எடுத்துக்கிறோம்னு வெச்சுக்கலாம். For example, nth shell is 4. Fourth shell தான் nth shell. அப்போ n minus 1 என்ன? 3. So if 3d orbital is involved in hybridization, அப்போ அந்த காம்ப்ளெக்ஸ் என்னன்னு சொல்லுவோம்னா, we call it as inner orbital complex or low spin complex or spin paired complex. Suppose if we consider the same nth shell, that is 4d எடுத்துக்கிறோம், nd orbital எடுத்துக்கிறோம் அப்படின்னா, if the nd orbital are involved in hybridization, then we call that complex as outer orbital complex or high spin complex or spin free complex. Inner orbital complex க்கு பேரு spin paired, outer orbital complex பேரு spin free complex, where this n represent principal quantum number that we know. So if inner orbital complex இருந்ததுன்னா, the hybridization is d2sp3, which will give low spin complex or inner orbital complex. Outer orbital இருந்தா வெளியில இருக்குது sp3d2. அப்போ we have high spin complex or outer orbital complex. Now the complex containing the central metal atom with unpaired electron. Unpaired electron இருந்துச்சு, சிங்கிளா இருந்தது அப்படின்னா காம்ப்ளெக்ஸ்லாம் ஃபார்ம் ஆயிருச்சு. Single electron, unpaired electron இருந்துச்சுன்னா, then the complex is paramagnetic. அல்லது செகண்ட் டயக்ராமில் பார்த்தீங்கன்னா தெரியும், ஃபர்ஸ்ட் டயக்ராமில் I gave you 3 single electron, அந்த மாதிரி இருந்தால் it's called paramagnetic. Suppose if the electrons are paired இருந்துச்சு, செகண்ட் டயக்ராமில் இருக்க மாதிரி இருந்ததுன்னா, then the complex is diamagnetic. If the complex is paramagnetic, then the paramagnetic moment mu s is calculated using the formula square root of n into n plus 2 Bohr magneton, where n is nothing but number of unpaired electrons. Ligands can be classified into two types, strong field ligand and weak field ligand. Strong field ligand na enna? Strong field ligands are nothing but like carbon monoxide, cyanido, ethylene diamine and amine. What do? They cause the electron to get paired. They cause pairing of electrons present in the central metal atom. Okay. Then the last point is, if the overlapping between the ligand orbital and the hybridized metal orbital greater is the bond strength. எவ்வளவுக்கு எவ்வளவு overlapping நடக்குதோ அதுக்கு தகுந்த மாதிரி they'll have greater bond strength. Here are some of the shapes: square planar, tetrahedral, trigonal, bipyramidal and octahedral shapes are given. Just have a look. What are the applications of valence bond theory? We can compare the geometry and magnetic property of certain complexes. Let us see one by one. Let us find out the magnetic behavior as well as the hybridization in nickel tetracarbonyl. Nickel tetracarbonyl, the complex will have the formula NiCO4. Now, which is the central metal atom? Yes, nickel. What is the oxidation state here? Carbonyl is a neutral ligand, so nickel will obviously have zero oxidation state. So nickel atomic number 28. அப்போ electronic configuration என்னவா இருக்கும்? Outer electronic configuration 3d8 4s2. The outer orbital of the metal atom I have shown you in the form of நமக்கு ஏற்கனவே தெரியும் எப்படி எழுதணும்னு சொல்லிட்டு. Hunt's rule வச்சு 3d ல 8 electrons இருக்கு, 4s ல 2 electron இருக்கு, 4p ல electron இல்ல. Now, which is the ligand here? CO. CO ங்கிறது எந்த type of ligand? Already according to valence bond theory, carbonyl is a strong ligand, strong field ligand. அப்போ strong field ligand என்ன செய்யும்? It will cause the electron to get paired. எந்த எலக்ட்ரானை பேர் பண்ணோம் அப்படின்னா அந்த 4s எலக்ட்ரானை கொண்டு வந்து இந்த 3d எலக்ட்ரானோட பேர் பண்ண வைக்கும். அப்போ என்ன ஆகுது? அங்கே இருக்கக்கூடிய 4s எலக்ட்ரான் 3d ஆர்பிட்டால 2 சிங்கிள் எலக்ட்ரான் இருக்கிற இடத்துல வந்து ஒன்று ஆக்கியூபை பண்ணிக்குது. இப்போ எந்தெந்த இடத்துல வேக்கன்சி வந்துருச்சு? 4sம் வேக்கண்ட், 4pயும் வேக்கண்ட். ஆக்சுவலாக எத்தனை லிகேண்ட் இருக்குது? 4 லிகேண்ட் இருக்குது. என்ன வேலன்ஸ் பாண்ட் தியரி என்ன சொல்லுது? According to valence bond theory, the central metal atom make available enough number of vacant orbitals. இல்லையா? எத்தனை லிகேண்டு? 4 லிகேண்ட். அப்போ 4 வேக்கன்சி இருக்கணும். இங்கேயும் the central metal atom will create 4 vacant orbitals, 1 in s orbital, 3 in p orbital. ஸோ இப்போ இந்த இந்த எஸ்ஸும் 3pயும் ஓவர்லேப் ஆச்சுன்னா நமக்கு என்ன கிடைக்கும்? will get sp3 hybridization. sp3 hybridization. அந்த hybrid orbital வந்து எது overlap ஆகும்? It will be hybridized. The hybridized orbital of central metal atom will be mixed with filled ligand orbital and they form covalent coordinate bond. So hybridization sp3 அப்படின்னா geometry என்னவா இருக்குன்னா tetrahedral geometry. அங்கே எத்தனை unpaired electrons இருந்தது? பார்த்தீங்கன்னா முன்னாடி எல்லாமே ஃபில்டாக இருக்குது, எல்லாமே பேர்டாக இருக்குது. There is no unpaired electron at all. So the magnetic property is diamagnetic. We say it as diamagnetic. And the magnetic moment, you know, it is mu s is equal to square root of n into n plus 2 Bohr magneton, which will be equal to 0 because number of unpaired electrons n is equal to 0. And here I gave you the shape of nickel tetracarbonyl. In the question paper, they will ask you to compare the magnetic property of nickel tetracarbonyl and nickel tetracyano complex. In nickel tetracyano complex, NiCN4 2-, you can see this Ni is in +2 oxidation state. அதை எப்படி oxidation state கண்டுபிடிக்க நம்ம சொல்லி கொடுத்துருக்கோம். x minus 4 is equal to -2. அப்போ x என்னவா இருக்கும்னா +2 இருக்கும். அப்போ நிக்கலுக்கு +2 oxidation state. What is the atomic number of nickel? Nickel is 28. So 3d8 4s2. In nickel 2+ state, the electronic configuration will be 3d8 4s0. Now, which is the ligand? 3d8 4s2 4s0. So electronic configuration is given. Now, according to what is the nature of ligand? Which is the ligand? Cn-. Cn-, as you know, it is a strong field ligand. What does it do? it will cause the electron of 4s orbital or 3d orbital to get paired. இங்கேயும் என்ன பண்ணுதுன்னா அந்த 3d orbital உள்ள தள்ளுது. ஒரு 3d லாஸ்ட் ரெண்டு 3d எலக்ட்ரான்ஸையும் ஒன்றா பண்ணுது. அப்போது என்ன ஆகிடுது, ஒரு வேக்கன்சி d ஆர்பிட்டல்லே க்ரியேட் ஆகிடுது. ஆக்சுவலாக எத்தனை லிகேண்ட் இருக்குது? there are 4 ligands. அப்போ எத்தனை நமக்கு ஆர்பிட்டால் வேக்கண்ட் ஆர்பிட்டால் வேணும்? 4 ஆர்பிட்டால்ஸ் இருந்தால் போகிறோம். இங்கே ஆல்ரெடி ஒரு d ஆர்பிட்டால் வேக்கண்ட்டாக இருக்குது. அப்போது வேறு இன்னும் எத்தனை ஆர்பிட்டால் வேணும்? 3 இருந்தால் போகிறோம். அப்போது ஒரு d, ஒரு s, அப்புறம் p ஆர்பிட்டாலில் 2 எடுத்துக்குது. ஸோ the hybridization will be dsp2. what is the hybridization? dsp2. and the dsp2 orbital now the electrons of ligand will come and occupy its positions. Okay, what is the geometry for dsp2 hybridization? Yes, it is square planar. How many number of unpaired electrons are present in that previous shot? 0. There is no unpaired electrons, so all the electrons are paired. So there is no unpaired electrons at all, so it is diamagnetic. Nickel tetracyano complex is also diamagnetic, and so the magnetic moment will be 0 because number of unpaired electrons is 0. Square root of n into n plus 2 will also become 0. The shape of nickel tetracyano complex is given, which is square planar. Nickel tetracarbonyl and nickel tetracyano are actually having coordination number 4. Now let us see a complex with coordination number 6. For example, FeCN6 3 minus. What is the atomic number of iron? It is 26. So the electronic configuration will be 3d6 4s2. In FeCN6 3 minus, the oxidation state of Fe is plus 3. So Fe becomes Fe3 plus. Now 2 electrons from s orbital goes out and 1 electron from d orbital goes out. So you have 3d5, perfect half filled configuration. Now outer orbital metal atom or ion will have all the 5 electrons singly occupied in 3d orbital. 4s and 4p are vacant. Which is the ligand? Cn minus. What type of ligand it is? It is a strong field ligand. What does it do? It causes pairing of electrons, either 3d orbital electrons or 4s electrons. Here only 3d electrons are there, so it starts pairing the electrons. What will happen? Outer electron, the last 2 electron goes to the first 2 orbital, and so you will have only one single electron left in 3d orbital. How many vacant orbitals are required? The coordination number is 6, so we need 6 vacant orbital. So you have already d orbital 2 vacancy, 1 s orbital, 3 p orbital. Totally 6 orbitals are available. So you will have d2 sp3 hybridization with the coordination number 6. These hybridized orbital of the metal atom will form complex with the ligand orbital. What is the hybridization? d2 sp3. If hybridization is d2 sp3, what is the geometry? Yes, it is octahedral. You know that d2 orbital is involved, that is d2 sp3. n minus 1 d orbital is involved in hybridization. If n minus 1 d orbital is involved in hybridization, then it forms inner orbital complex or spin pair complex. Here we have in FeCN6 4 minus complex, FeCN6 3 minus complex, we have inner orbital complex. How many unpaired electrons are present? There is only one unpaired electron, so it is paramagnetic. How will you calculate magnetic moment? Mu s is equal to square root of n into n plus 2 Bohr magneton. If n is equal to 1, then mu s will be equal to square root of 1 into 1 plus 2 Bohr magneton, which is equal to 1.732 Bohr magneton. Same way, let us find out the hybridization and geometry in the case of COF6 3 minus complex, which is a central metal atom CO. What is the oxidation state of CO? If F6 is there, minus 6, X minus 6 is minus 3, so CO will be plus 3 oxidation state. What is the atomic number of cobalt? It is 27. If it is 27, that electronic configuration will be 3d7 4s2. In CO3 plus oxidation state, 2 electrons from 4s orbital leaves and 1 electron from 3d orbital goes. You will have 3d6, 4s0 as the electronic configuration. Now the orbitals will have electrons filled. 3d orbitals will have 6 electrons, 4s is vacant, 4p is vacant. How many vacant orbital we need? We need 6 vacant orbital. Okay. What is the type of F minus? F minus is a weak field ligand, and hence it will not allow the electrons to get paired. So all the 3d electrons will be as it is. How many orbitals we need? We need 6 orbitals. But how many orbitals are present? Only 4 are there. So what do the atom does? It takes the electron from 4d. It takes the orbital from 4d. That means 4s, 4p and 4d orbitals are involved. You will have 1 s orbital, 3 p orbital and 2 d orbital involved. You will have sp3 d2 hybridization with the coordination number 6. So these 6 orbitals will undergo complex formation with the ligand filled orbital. Here the geometry will be as usual sp3d2, so octahedral. Now nth shell, nd orbital is involved. If nd orbital is involved, it will form outer complex, outer orbital complex or spin free complex. Okay. How many number of unpaired electrons are present? There are 4 unpaired electrons, and so it is paramagnetic. If there are 4 unpaired electrons, the magnetic moment will be square root of 4 into 4 plus 2 Bohr magneton, which will be equal to 4.899 bm. The shape is given here. Here you must see, they'll give you the magnetic moment value. They may give you 4 point something, 3 point something, 2 point something. They'll ask you number of unpaired electrons. You can take from the first decimal. That is, if they give you 3 point some value, you can give the n value as 3. If 2 point something is given, then we can write n value as 2. Okay. What are the limitations of valence bond theory? It could explain magnetic property, but it could not explain the color of the complex. Also, it considers the spin only magnetic moment, and it does not consider the other components of magnetic moments. It provides information regarding inner orbital complex and outer orbital complex, but it cannot explain why only certain complexes are forming inner orbital complex and other are forming outer orbital complex. For example, FeCN6 4- is low spin diamagnetic complex, and F6 4- is paramagnetic and high spin complex, which could not be explained by valence bond theory. Here is unit test 4 for about 40 marks. Please answer all the questions. If you have any doubts, you may ask your teacher. Thank you. So your video part 5 of coordination compounds will reach you soon. Finish this. Like, share and subscribe for next video. Thank you.